Hello, everyone, and welcome to chapter 28 of this Flutter course. In previous chapters, we've been talking quite a lot about CRUD, create, read, update, delete, and we talked about how we can, for instance, have raw functionality in our node service so that we can read from the database, delete stuff from the database, create users, etc., etc. Now, we haven't really worked in the past two chapters so much with our user interface, and that's completely okay because sometimes as you're developing applications or you're developing software, you may have to take detours in order to create the functionality that is later going to be needed for your user interface. And you'll do the same thing if you're doing backend development, like web development. So I myself do web development with Django, and sometimes I have to go and create a lot of functionality on the backend first before I can actually go and mirror that functionality on the UI, which is, for instance, the web browser where the user is consuming the content. So, and even if you're a designer, for instance, you're working with Figma, you can't always produce user-facing content like prototypes. You may have to sometimes go and design first your components, and then after you've done your components, then you'll be ready to put those components into screens and display that to your product owner or your developers. So, so far we've been working a lot with what the user doesn't see, and we have to like stitch up those last bits and pieces before we can actually go to the UI and manipulate that data, which our notes service can right now manipulate. We're missing a few functionalities which we're going to develop in this chapter in the notes service. And what we're going to work with in this chapter especially is with streams and stream controllers. So let me bring up the caption that I'm going to talk about now. So what are streams and what are stream controllers? Well, if you are a developer already, you've done software development, you may know something about reactive programming. And reactive programming is where you have a bunch of data sitting somewhere, for instance, and then you perform some operations on that data, and this data gets updated, and you will be notified of these updates through some sort of a pipe of information. And if you haven't done software development before, so reactive programming and stream controls may be a little bit overwhelming, but we're going to start very slow. So there's nothing to be worried about. I'm going to explain everything as much as I can to make things easier for you. But if you don't have development background from before, software engineering background, there's not so much that I can explain about streams and stream controllers for you to completely understand how they work. All I can say is that imagine a stream is just a point of time, or a stream is basically an entity that controls data. All right, just say something that keeps hold of data, and then you perform things on it. So you say, add this data or remove this data, add this data with this data, and give me the results. So it keeps hold of its data, and it has a timeline. So it starts at some point, manipulates its data, and then it either errors out at the end saying that, oops, I can't do this, and then it just dies, or it will just complete at some point. And also there is a third category of streams where the data just keeps living on. So it never basically completes or errors out. So just think of streams as pipes of data, pipes of information that you can manipulate and you can also perform operations on. So if that's what streams are, then what are stream controllers? In Dart, a stream controller is your interface to your streams. So you have the stream, which is sitting right here, and you don't basically usually go and add stuff to a stream directly or read stuff from the stream. What you can do is to have a stream controller where you're manipulating the stream, for instance, our note service. And this stream controller is able to, for instance, add stuff to the stream or read stuff from the stream. So just imagine the stream controller is kind of like the manager of that stream. So if all of this sounds a little bit high level and abstract, I completely understand that. It usually is when you're working with reactive programming. Some people actually hate reactive programming, but as one of my colleagues used to say, it's always easier to hate than to learn. And my approach is usually, if I hate something, is because maybe I haven't really fully understood it. So there are very few things in my life that I've actually learned which I hated after learning. So if you're a bit overwhelmed by streams and stream controllers or reactive programming, don't be. They're actually really good if you know how to use them. So they're very easy to use as long as you get a handle of how basically it's getting a handle of the right way of using them. So that's what I'm going to show you in this chapter and the upcoming chapters as well. So let's go, excuse me, let's go to our application. I'm going to put the code right here. Let's have a look at what we've written so far. I'm going to increase the size of the screen and then decrease the font size a little bit so it's not as ginormous. So um, let's have a look at what we've done so far. You can see we have quite a lot of functionality in here. We have, for instance, delete all notes, and we have get all notes. We have update notes, so quite a lot of functions. Uh, but if you see, all of these are directly talking with our database, with our SQLite database. None of these functionalities are actually telling, or we don't even have to talk about the functions, but if you look at the note service in it itself, it doesn't contain a list of notes. So it doesn't have the ability to cache these notes. So it's, as soon as you give it a command, the note service says, I don't know what to do. I'm just going to go to the database and do what you said I have to do. However, this could, I mean, not in our application, but in an application that has millions and millions of rows of data, for instance, this could not be such a good idea that you always go to the database and read the entire thing in order to, for instance, delete one row. Or basically, these operations should kind of be like cached inside your application before you go and hit the database, hopefully. And what we're going to do, as you can see in the caption here, we're going to actually start caching a list of notes that the note service has. So the goal is for the note service to be able to expose a list of notes that the UI can then render on the user screen. So if the user goes and presses the plus button, then that plus button is then going to send a message here to our note service. We're going to then go to this function, create note, and this create note function internally is then going to manipulate that list of notes inside note service, say, hey, here's a new note, add that. And then our UI is going to listen to a list of these notes available in the note service. And if things change in that list, then the UI is just going to automatically update itself. And this interface between the UI and the node service is going to be done through a stream. Okay. I know it's a lot of information, but you'll get it. You'll get it as long as we go through this chapter together. So what we need to do first is let's go, and as the caption at the bottom of the screen indicates, we're going to go and expose a list of notes in our note service. Okay, so let's go ahead and say we have a list of database notes, and we're just going to call it notes, and we're going to start with an empty list. All right. So that's really good. Now we have, let's say this is our cache. This is where we're keeping all the notes that this note service manipulates. All right. So now let's go and talk a little bit about our stream controller. So you see, what we need to do, as the information here says, what we need is for the note service to be able to control a stream of notes. So when the list of these notes changes, we need to tell our stream in the note service that, hey, some element got added, hey, some element got deleted, or some element got updated. So then the UI can then reactively listen for these changes in the note service, and we do that through the our stream controller. So let's go, as the caption indicates. I'm going to write it notes. Actually, maybe I should. Yeah, I'm going to write it notes stream controller. And the way to create a stream controller is that you just say stream controller, and then you specify the type of data that your stream contains, which is a list of database nodes. And then we're going to just say dot broadcast. Like that. And I believe stream controller isn't yet, excuse me, isn't imported in our notes service. So I'm going to get help from Visual Studio Code. And you can see it says that, well, stream controller is available in the Dart async package. So, and yeah, async meaning asynchronous. So in order to be able to use stream controller, you have to import that. So I'm going to get help from Visual Studio Code to do that. All right. So let's see what we did in here. What is this? The syntax looks really, really scary, but it really isn't. All you're saying is that I want to be able to control a stream of a list of database nodes. Basically, you're saying that I have a pipe. This pipe, every event that is inside this pipe is a list of database nodes. So let's say you start with an empty list. So this list is empty inside this pipe. Then you add an item to this pipe. Then what it does is says, oh, What was I before? I was an empty list. Add that new item. So now I'm an item. Now I'm an array or a list with one item. And then it puts that array inside the stream. So the stream's value is now at the beginning was empty list, then it's a list of one item. So the stream controller is basically in control of, as its name indicates, is in control of the changes to this node's list. It isn't hooked to that yet, but that's its purpose, and that's the reason it has the exact same data type in its stream controller. Now, the broadcast part in here, as you can see, the documentation actually spot on. It says a controller where stream can be listened to more than once. And if you've done Dart development or Flutter development from before, you may know that if you then and I'm now assuming, as I said, that you're a Dart or a Flutter developer from before. If you have created a stream controller and then you go and listen to the changes to that stream that the stream controller is controlling, and then you do a hot reload, then you get an error from your Flutter application saying that, oh, this stream's already been listened to, so you cannot listen to it again. And that's the problem that normal stream controllers can cause, and that you, as soon as you've listened to them, you should close your listening channel to that stream before you can listen to them again. So that's what broadcast fixes. If you're not a developer from before, what this broadcast basically is saying is that it's okay for you to create new listeners that listen to the changes to this stream controller. So here's a pipe of information. At this point, you start and listen, and then it's completely okay that if you want to listen to changes to the stream controller later in the future as well. So you're not going to get any errors by doing this broadcast. All right. All right. Now, what we need also is a handy function in our application um, that can read all the available notes from our database and then cache them inside both the notes cache right here and our controller. Okay, so you see what our goal in this chapter is to make sure that this is the source of truth, that our notes list contains all the notes for instance, the current user. Then the stream controller is our interface to the outside world. The UI is going to be listening to changes that occur in this stream controller. So whenever you see this is not something that's going to be read from the outside. Everything's going to be read from the outside through this. All right. So keep that in mind. So let's go ahead, as a caption indicates, and we're going to create a function in here called cache notes. And its purpose is just to read all the notes from the database and place it both in here internally and in our notes stream controller, which is going to be read externally. All right. So let's go and do that. So I'm going to say future void, and we're going to call it cache notes is async. Then, if you remember, we already have an async function called get all notes. So I'm just going to say final all notes is await. It's all notes. Okay, so that's going to get all our notes. Then we're going to assign that to our list of notes in here. Okay, so let's go in here and say, as you remember, get all notes returns an iterable of all our notes. And now we have a little bit of a problem here because we're saying list of all notes, and in here we're also saying list of notes. So we have to convert that iterable to a list of all notes. Okay. Either we could do that, or we could have this just sit there as an iterable. It's completely up to you. I have no issue with any. We could just go with list. So let's go in here, and then we're going to say our notes is, the private notes is all notes to list. And we also are going to update our stream controller with that, with the value of underscore notes. Okay. So we're going to say notes stream controller, if I can spell. And then we're going to add notes to the stream. And remember, a stream is just the evolution of a value through time. And the first point of this evolution was an empty list. And then the next one is going to be the notes that are, all the notes are in the database. Okay. So that's just, we telling anyone listening to the stream controller that, hey, here's a new value. All right. Okay. So Now that we're doing this, you can see we're getting an error. And Dart is actually, this analyzer is so clever because you see it's telling us that the cache notes function is not being used. Now, you may be asking yourself, well, none of these functions are being used. Update note, for instance, is not being used. So if I search for update notes, let's see, update notes, could not update notes. So yeah, you can see that update note function in itself is not being used at all. So why is it that the analyzer is complaining about this function particularly? And the reason is because we have a little prefix behind this function name. And this prefix is telling the analyzer that this function is private and private to this class. Now, Dart Analyzer is looking at it and it's like, okay, this is a private class, but you're not using it. So the reason that other functions aren't being marked with this warning is that Dart understands that they are not prefixed with an underscore, meaning that they're going to be used publicly somewhere else. So it's not going to yet give us any warning saying that you haven't used those functions. As soon as you remove that, you see that the warning also goes away. But we're going to keep the underscore. Okay, I just wanted to explain to you why you're seeing this little warning here. Okay, now that we've done cache notes, what we're going to do is just to go to our, as a caption case, we're going to go to the open function. Let's see if we can find it here. Open. And upon opening our database, so let me have a look at my notes. Upon opening our database, we are going to cache all those. Let me just have a look at my notes. Yeah, we're going to basically go to the open function that we have here, future void open. I'm a bit surprised that I actually haven't written any notes about that. Yeah, I can see actually I have, so that's good. Okay, so right after executing this command for creating the note table, after we created the user table and note table, now that we know that we could open the database, we also have to cache all the notes in our local variable. So let's just go and call that function. So we're just going to say await cache notes, okay? So this means that when you call this open function, if after we made sure all the tables, everything is there, if they didn't exist, then we're going to read all the notes and place them inside this notes variable and also in this stream controller. Okay, so that's how we did the cache notes. And I hope that you could see the code and it wasn't hidden by the caption at the bottom of the screen. All right, so that part is done now. Now, what we need to do in here is to go to the next part of the code. And as you can see, it says cache note in create node. In create node function, add the new note to underscore notes and the note stream controller. So I'm going to go to my notes here, create notes, and ensure that when we create the notes in our creates note, right here in this function, in the create node, you see at the moment what we're doing is that we're just creating a node and returning it. That's good, but I mean, it's not good enough because as I said, we need the UI to be able to reactively listen to all the nodes that are right now in the database for that current user, okay? So in here, after we create the node, we're actually gonna add it to our array of nodes, and then we're also gonna add it to our stream controller. So I'm just going to go in here and say nodes, add this new node in there. And also remember the stream controller's responsibility is just to reflect the values inside the underscore nodes to the outside world. So all we have to do is just to say nodes, stream controller, add nodes, just like that, because nodes is the source of truth, as I mentioned before. All right. Great stuff. Now we need to take care of the other function called delete node. Let's search for that. Delete nodes. All right. So what we need to do is to have a look at this functionality here. And you can see it says, if we couldn't delete anything, then throw this exception. But now we're going to add an else statement in here. And by us being able to delete that node, meaning that you can see the node ID we have, which is this ID. So what we need to do, as the caption indicates, we need to actually remove that node also from our local cache. So we're going to say nodes, remove where, and this is the node. And then I'm going to say node.id should be equal to that ID. And after doing that, we could just say node stream controller add notes. And you could you could try to be clever in here, and you, for instance, could say, oh, you see that who says that that node actually exists in our cache? We can't 100% be sure about that. But if you look at the signature of the remove where function, removes all objects. Oh, maybe we don't have the ability to actually know if that node was deleted. But what you could do, you could just say count before is nodes count, and then you could in here or length. And here you could just say if nodes length is not count before, then you can update your stream. I don't plan to do that, but you can try to do that if you want to. It's just a safeguard for you to say, I'm gonna update my outside facing stream only if I actually could delete this node from my cache. If you think it's worth it. I don't think it's worth it, but that's just an opinion. So we're gonna leave it like this, as the caption also indicates. Now you see we also have a functionality to delete all nodes. So let me find that function, all nodes. All right, so let's go in our delete all nodes in here, find that function, and you can see right now what it's doing is just returning the number of deleted nodes. Now what we're going to do, we're going to say final, what should we call it, number of deletions is equal to this, and we're going to return that number of deletions. Okay, because I mean I'm doing that simply because we need to do some work in the middle here. Okay, so then what we're going to do is going to say notes is an empty list. All right, so we're resetting the notes, and then after doing that, we're also going to update our stream controller. So we're going to say add the underscore notes to the stream controller and then return the number of deletions. So this makes sure that our local cache is updated, and also that the user facing interface of our class, which is the stream controller, is also updated with the latest information. Okay, next thing that we need to do, as you can see in the cache, it says update caching, get node, remove old node with same ID, and add the new one and update the stream. So let's go to our get nodes. Okay, so let's have a look at our get node in here then. And at the moment, as you can see in here, what it's doing is, oops, that's not get node. Here is get node, right there. Okay. And as you can see here, we're basically, what we're doing is that we're saying, upon you trying to read a node from the database, we're literally just making a query to the database. And then if we could find that item, we are returning it by creating a database node from a row that you can see right here. But what we're going to do is that if you try to get a node, there is a possibility that we already had that node cached locally in our nodes array, but that node is outdated, meaning that the copy that we had in our cache is not really updated with the latest changes that have been applied to the database. So it makes good sense right here to now, upon creating a new instance of database node, actually to update our local cache as well. Okay, so I'm just going to say final node is equal to that, and we're going to return that node. In the middle right here, so this code is the exact same as it was before, except we're now assigning the return value of from row to a new local variable here. Okay, so let's go to our notes and say remove where, and I'm going to say in here note, and I'm going to say note ID should be equal to ID, which is this thing here. Okay, so we first remove that node, existing node, from the notes array. Then we say note add, and we add the new nodes in there. And then what we're going to do is right after that update the stream controller, which is our outside facing interface. So node stream controller add nodes. Okay, so you can see this pattern. So we first always update our local cache, and then we reflect those changes to the outside world. All right. All right, great stuff. So that's for node stream controller and nodes. Now there's another function which is called update nodes, and let's go to update node actually before we have a look at anything else. And you can see in here, when we update node, first we make sure that that node exists. So let's put actually a comment in here: make sure node exists. And then we say update DB. I'm going to expand this code so you see better. That's the update DB part. And if we couldn't update anything, then we throw could not update note. And you can see that in here, upon doing an update note, what we want to do is, I mean, it is quite clever what we've done so far, because it means that we've updated the database. But what we do then in order to return the new refreshed note is that actually we call gets note. So that's pretty good. So, but what we also need to do is just to make sure our local cache is also updated. So let's go in here and say final updated note. And what we're going to do, as the caption at the bottom of the screen indicates, we're going to remove that note from our local cache and add the updated note in there, and then send the add message to our stream controller as well. So let's just say notes remove. So we are going to remove the old object from our cache, and I'm just going to say notes. As long as the notes ID is equal to the updated notes ID. So that's going to remove the existing note. And I'm going to say notes add, and we have the updated note in here. As soon as you change your notes local cache, then you need to also update your stream. So the stream controller add notes. All right. And then we return the updated note in here. So what happened in here is just that we updated something in the database. We got the new object from the database. We removed that note from a local cache, and then we added it in there. Okay. Added it back as the updated note. All right. All right, great stuff. That's for update notes. And then what we need is, as the caption indicates, is get or create user in notes service. So this is a function that we're going to actually use in the next chapter. So how is this function useful? This is the first time we're actually seeing the signature for this function. As the name indicates, it says get or create user. You see, when you at the moment go into our user interface, let's go to the login view, for instance. Login view here. I'm going to remove the Explorer so you see the code in its entirety. Right here, when we do auth service Firebase login, then we get the current user. If the email is verified, is that we're going to notes route. Now let's then go to our notes view. You can see right now, notes view, the only thing it's doing is that it's creating an app bar with it's creating a scaffold with an app bar that we have our logout button in. And let's go, let me bring up strcpy. So I'm going to use my email address in the login screen. So I actually may need to go and connect this device to Wi-Fi. So boom, I'm going to open up, I'm going to log in with my user. So I'm going to get rid of all those. I'm going to log in here. We've sent you an email verification. Okay. Maybe I should actually log in with the user who has already been verified. So let's log in with this user. You see in the main UI of the application, of our application, we have this hello world right there, because you can see the body of our notes view right now, it just says hello world. So you could pretty much say that the notes view has literally no contact at the moment with the notes service. But we're going to fix this soon by first making sure that the notes service allows the user interface to create a new user upon going to the screen. So when we come to the screen, we need to make sure that there is a user associated with the current Firebase user inside our database, okay? So that's what we need, this little good function called get or create user, which returns a database user in our notes service. So we're going to use that in the next chapter. So remember that, okay? But we need to create the function at least right now. All right, let's go then and create this function as the name indicates. So future and database user. And we're going to say get or create user. And it has a required parameter, I can see, required string email. And it's an async function, right? So we need to basically have a look at this, how we can create this user. So The goal in here is to first we try to get this user from the database. If that user doesn't exist, then we're going to create that user. And then in both cases, we're going to return either the fetched or the created user back to the caller. So let's go in here and just say final user is await get user. Okay. And you see the email just fits in there perfectly. But if you remember from the implementation of get user, let's go in there and expand this. If the user couldn't be found, then it throws an error, says could not find user. That's our cue, so that if that function throws that error, then we're going to create that user. So if that user doesn't exist in the database, it needs to be created. So let's put a try statement in here, and then we're going to say on could not find user. So here is the user. So in this case, in the try statement, it means that we could get the user. Okay, so if we get to this return statement, it means that get user function didn't throw any exception, such as could not find user. In the case of a could not find user, we're going to actually create a user. So let's just say created user is await create user with that email, and then we're going to say return created user. And if you look at the create user function as well, right here, it also, I believe, does it throw? Yes. So if it couldn't create that user, if it's the result was empty, it just says user. Oh no, that's where we get the user. Sorry about that. We need to have a look at this insert. So yeah, that's the only thing it's doing. So it's not basically throwing any other error. Okay. The only thing it does is says if you're creating a user that already exists, I'm gonna throw an error. So here we've ended up with a try and catch block that could also throw an exception, which we haven't handled. All right. So what you could do is just to do a whole catch in here and then don't do anything with it. I like this pattern quite a lot in my code, at least, because if I don't do this, then I don't actually have the possibility to debug my application later. So I can't put like a breakpoint in here and see, did any other exception arise? If you don't do that, because then the exception will be thrown to the caller, and the caller will have to handle that. But in this case, we're not really handling the exception. We're just catching it, and then we're throwing it back to the call side. This only allows you basically to put a breakpoint in here if you want to debug your application later. Okay, so it's just a quite a cheap way of making your code easier to debug. All right, for those of you who are interested in this. All right, fantastic. We've covered a lot, and there's still a lot to do. But we've come far, so congratulations. Let's have a look here. It says, let's get ready for the next chapter. And upon logging in, we need to call our get or create user function and have the user ready. And this is what I mentioned to you before. Inside our notes view at the moment, we don't have any functionality that creates a new user or gets the current user based on their email if they already exist in the database. And that is going to be like the actual first bit of logic, which we're going to do in the next chapter, which integrates our notes view with the note service. So the tempo of our course right now is going to shift towards more and more to the notes view until we have a list of notes and allow the user to create notes, update notes. So it's exciting times. We've come far. We've done quite a lot of work up to this point, and there's still a lot left, but hopefully you're getting the tempo of the course better and better, and you can see why we're doing things the way we're doing. So congratulations again, and get some refreshments if you want to. Again, coffee, tea, and I'll see you in the next chapter.